students in our class, but if we were talking about something continuous, like the weight of a baby, or the time that has passed, those continuous variables, we need something different, so that's our motivation for the normal. When you graph a normal distribution, what does it look like? It's the bell shape. Okay, so it's always symmetric there. So today, we are going to start calculating probabilities from the normal distribution. And what we want to be able to do is use a table to do that. But it's kind of hard. If you're looking at different sets of data, every set of data I take would have a different mean and standard deviation, right? And so we have to be able to take those and kind of put them in terms of a common unit. So that is the first thing we're going to do. We're going to talk about what's called a z-score, which is basically just taking any set of continuous data and getting it in terms of the same unit, so we could use one table to calculate all those probabilities instead of trying to do everything by hand. So what you need to write down is really just this formula. We use this for any normal random variable. So if we know it's normal, we will calculate the z. A z is going to figure out how many standard deviations you are from the mean. Okay, so we know, like, it's basically saying, okay, 0 is my center. When you're 1 standard deviation away, 2 standard deviations away. Sorry. A positive z-value would mean you're above the mean, and negative would be below the mean. Mu and sigma are the mean and standard deviation of your data. Your x is the value. So we'll always basically take our point, we'll subtract off the mean, and divide by standard deviations, and that will tell you how many standard deviations you are from average. Does everybody have that? If you look at the third page of your formula sheet, there is table 5. It says the standard normal distribution. This is the table that we are going to be using today. If you look up at the top, it gives you a picture of the bell curve, and it shows you, it's got the z marked, and then it's shading the area below that, the area to the left. So what this table does is it gives you the area basically below that z value. So if I said my z was 2, okay, you would come up here to 2, and your table would give you all of this area. So if you were all the way out here, what would you expect your area to be? 100%, 1. Because we know that under the entire curve, we have an area of 1. We've talked about interpretations for this. It can be talking about a proportion of the population that meets this requirement, or it's like a probability of something happening. So let's look at an example. IQ scores can be modeled by a normal distribution with a mean of 100 and a standard deviation of 15. Find the area to the left of a score of 120. All right, so if I just give you this score, that doesn't help me at all. If I go to my table, there's no such thing as a 120 on this table. So the first thing you have to do is calculate your z, which is the formula we just wrote down. If you also look on your formula sheet under Chapter 7, that is the first formula there. It tells you to find the z value. You're going to do distance from the mean. So it's your x minus your mu over your sigma. So my x would be what?
120.
Minus 100 over 15. All right, calculate that for me. What do you guys get? Go to 2 decimal places, please.
1.2.
Put that in parentheses.
1.3.
2 decimal places? 1.33. That's what I got. Okay. The reason I had to go 2 decimal places, normally we go to 4 with everything, but if you're looking on here, this table only has 2 decimal places for the z, so that's all we really need. Now, haven't we found z-scores before? Does this look familiar? Remember way back in chapter 3, we found z-scores. I think like on the test, I gave you a question, like on your history test, you got this score, and the mean was this, and standard deviation was this, and on your math test, you got this one, and which test did you do better? And we looked at it to interpret, to compare those. So we're doing the same thing here. So when you read your table, everybody look at this. I want to make sure we all understand how to read this. Okay. So across the side, you have these z's. So we have 1.3, so I'm going all the way down to my 1.3. And then I had 1.33, so I'm going to go to the 0.03 column. And so those meet at 0.9082. I asked you to give me area to the left. Okay, if you're looking at the top of that, this is like a 0 at your mean. That's when you're at 0. 1.3 is above the mean. The table gives you the area to the left, so that is the number I want. So it's just the 0.9082. What if I had asked you to find the area to the right instead? So, yeah. If I want the area to the right, if I want the probability you were above that, you have to do the complement. 1 minus 0.9082 is 0.0918. So far, so good? So really, guys, this is all we're doing. We're just practicing reading this table today. Let's look at this one. So if I wanted the area to the left of z equals negative 0.038. So negative, is that above or below the mean? Below. So you would expect your probability to be less than 50%, right? At the middle, that's 50. What did I say? Negative 0.38. Okay. So you go to negative 0.3, go over to your 8, and our probability is 0.3520. Everybody seeing that on your table? How do I get area to the right? Complement. 1 minus. My z is 1.25. So I go to the 1.2 and over to the 5, and we get subtract those, and we get 0.1056. Okay, C. We're going to have to think a little bit. I want the area between negative 1.02 and 2.94. Okay, negative 1.02. That's going to be below the mean. 2.94 is all the way out here. I want everything between those two. What would I have to do?
Take the area to the left of 1.2 and the right of 2.94, and then add them together and subtract 1.
Go to the chart and find the one for 2.94 and then the one for negative 1.02 and subtract.
Yep, two perfectly good options there. So the one that has fewer steps is probably Carly's option, but what Corey said worked just as well. He said find this out here, which we did area to the right, you just do 1 minus. Find this down here. He said then if you add those together, if you did 1 minus that, you'd get the rest of it. So that works perfectly well. The other option is if you did the 2.94 and you read that from your table, it's going to give you all of this. And then if you look up the 1.02, it's going to give you this, so you should subtract those two numbers. Okay, that works great as well. So let's do that second option. So if I look up my 2.94, I get 0.9984. And if I subtract off the negative 1.02, we get 0.1539. And so if we subtract those, we get 0.8445. And again, what we did is we did when the z was 2.94 minus when the z was negative 1.02. So anytime I ask you to find the area between two things, you just need to look up the higher z value minus the lower z value. Any questions so far? Let's look at this example. So a pediatrician finds the heights of her female 3-year-old patients are normally distributed with a mean of 38.72 inches and a standard deviation of 3.17 inches. So mu is 38.72 and our sigma 3.17. I need to find the proportion of 3-year-old females with a height less than 35 inches. So we are finding the probability that your x is less than 35. Now, can you go to your table and look up 35? No. So what do I need to do with this before I can actually calculate my probability? Yeah, we need to change it to a z. So to get your z, you do your x minus your mean divided by your standard deviation. We really just need 2 decimal places because that's all the table goes to. So I need the probability that my z is less than negative 1.17. So if you are doing less than, what do we have to do?
To the left.
Yeah, that's area to the left, which is what our table gives us. So we just need to read that probability from your table. Okay, so everybody try it first before I write the answer up here and make sure we can find it. I don't want you just watching me do it, I want you making sure you can find them on the table yourself. Should get 0.1210. Everybody find that on the table? So next one. Find the probability that a randomly selected 3-year-old girl is between 35 and 40 inches tall. So we need to be between the 35 and the 40. Okay, what do I have to do? Okay, we need the z's for both of those. When your x is 35, we already found that our z was, yeah, your stuff had that. No, you're good. When your x is 40, then you would do 40 minus 38.72 divided by 3.17. So, I'm finding the probability that my z is between negative 1.17 and for the second one you get 0.40, right? Technically, guys, on these, it's not going to matter if it's less than or if it's less than or equal to. Okay, we're going to look it up the same way. So when it's between two values, I told you look up the higher number and then subtract off the lower number. So when my z is 0.4, go to your table, 0.40, that's 0.6554. Minus when our z is negative 1.17 from part A, that was 0.1210. So if we subtract those, we get 0.5344.
How do we know which one goes first again?
You always will do the higher one first.
So it will never be negative?
No. Think of this, your final answer is a probability. And probability has to be between 0 and 1. So if you did it and you got a negative, you would know, uh-oh, that's not possible. I need to flip this. Other questions? All right. Let's go to this one. So the combined verbal plus quantitative reasoning score on the GRE is normally distributed with a mean of 1,049 and a standard deviation of 189. What is the score of a student whose percentile rank is at the 85th percentile? Okay, this is taking us back a little bit. Remember we were talking about percentiles a long time ago? So when it said the 85th percentile, that means you scored 85% of the people were less than or equal to your score. Okay. So if we know the percentile is the 85th, or the 85%. So that's like our probability here. Since the 85th percentile, everybody, 85% are less than or equal to you, isn't that what the table gives us? The table gives us less than. So what this means is to find the z with the probability equal to 0.85. So you are now looking at your table, you are looking inside the table and trying to find 0.85 on the inside of this table. Okay, so we want to get as close to that as we can. So we're working backwards. So I'm looking for when my probability was 0.85. So if I see here's 0.8485 and 0.8508. So I'm not going to be able to be exact here. Which of those is the closest that we can get to 85%? 0.8508. So we're going to use this one. So then the z that matches that is 1.04. Right, so you found 85% in the table, as close as we could get. And then we read the z was 1.04. Does everybody see where I got that? Now, I didn't ask for the z, I asked for your actual score on the test. I want to know, what did you do on your test if you got the 85th percentile? So, we know that to find the z, that's your x minus the mean divided by the standard deviation. So the z is 1.04. We don't know the x. What was the mean? And our standard deviation? 189. All right, everybody find x for me. So go ahead and solve this. Multiply over your 189, then add the 1049. And so you should get a score of 1245.56. Or you could say you scored about 1246 on the test. Okay. I'm going to put another question up here. I want you guys to read it first and think for a second about what our strategy might be before we talk about it together. So I want everybody to see if you can decide what we would need to do here. So we know it's a normal distribution. The mean is 100. Standard deviation is 0.45. You want to accept 90% of all rods manufactured. Determine the length of the rods that make up the middle 90% of all steel rods. So if we think about our normal distribution, we want to take this middle part, and that is 90%, so that's 0.9. What you want to do is basically throw out the smallest few and the largest few, right? Okay. What percent of your rods are you going to throw out? 10%. So what percent would be down here, the smallest few? 5%, so that's 0.05. Okay, and we want 5% up here, right? So we're going to throw out the 5% that are the biggest and the 5% that are the smallest. Okay, so we need to find our z's that match this. Now, when we do this, our table gives us the percent less than that. So when I'm looking for this upper 5%, what percent is below that? 95. Okay, so I need to go to my table. When my probability is 0.95, that means my z is what? So everybody, look at your table here. We need 0.95. That's our probability. So that's inside the table. And we have 0.9495 and 0.9505. So it's right in the middle of those.
Is that 0.5 or 0.6?
It's 0.5. You're looking for when your probability is 0.95. So our probabilities are these numbers inside the table. I am trying to find 0.95, 95% inside this table. So if I do that, I look, trying to find the closest I can get to 95%. So here's 0.9495, here is 0.9505. Those are both equal distance from 95%, aren't they? So that's 1.64 and 1.65. So could we just say right in the middle of those would be 1.645, since it's right smack dab in the middle? So we know that one for sure then. We don't even have to guess. So that's when my z is 1.645. When I have the smallest one, that's when my probability is 0.05. So let's find the z that matches it. So I'm looking for 0.05 in my table. So let's see. So right here I have 0.0495 and 0.0505. So isn't it right in the middle of those two? So that is negative 1.64 and negative 1.65. So the middle of that would be negative 1.645. What do you notice about those two numbers? They're the same, because isn't the normal curve symmetric? Since we had equal percents on both sides, it's just a positive z for above the mean and a negative z for below the mean. Okay, so now I wanted the actual lengths. So I know z is x minus the mean over the standard deviation. So when my z is 1.645, the mean was 100, and my standard deviation was 0.45. So if I want to solve that, multiply over the 0.45, add over your 100, and you get 100.74025. For the other one, same thing. So your z was negative 1.645 equals x minus 100 over your 0.45. So multiply that over. Add your 100, and you get 99.25975. So the actual length of the rods, you will accept rods between, let's round this just a hair, 99.26 centimeters and 100.74 centimeters. So if you want to accept the middle 90% of your data, you have to take every rod between those lengths. So anything smaller than the 99.26 or bigger than the 100.74 would get thrown out.
Where did you get the 0.05 later?
That was the standard deviation that was given in the problem. Okay. Questions there? Last thing I need to show you. I need you to make sure you write this down. This is a notation thing, but it always throws people because it's the opposite of what you want to say. So everybody needs to write this down. Z alpha is the z-score such that the area under the standard normal curve to the right of z alpha is alpha. So what you need to write down, when you see a z sub alpha, this means the area to the right is alpha. So if I said z.1, that means I want 0.1% to the right. That's the opposite of the table. The table gives us area to the left. So this is one of those things that's slightly confusing, just because the table I've given you versus the standard notation. So when you see this, all you have to remember is alpha is the area to the right. So I'd like to do an example with that, and then I'm done. So let's say I've asked you to find the value of z.10. What that means is find the z value so that the area to the right is 10%. So when I'm looking at my table, what probability am I going to look for? 0.9, because the table gives me the area to the left. So I am going to my table, and I'm trying to find 0.9 in here, as close as we can get. So, let's see, I've got 0.8997, and then it jumps to 0.9015. So 0.8997 is as close as I can get. So that is at 1.28. I want you guys to do this one. So find z of 0.65. It's saying that 65% of the data is to the right. So what probability are you looking for? And you're trying to find the z value that makes that happen. So when you go to as close as we can get to 0.35, so I've got 0.3520 and 0.3483, so 3483 is closer. That's negative 0.39. Alright, questions on that? So that is the end of section 7.2, and also the end of what we're covering in chapter 7. This assignment is not going to be due until Wednesday, so you will have class time tomorrow to work on this. I think what I'm going to do, I really don't want to start chapter 8 with the extended weekend coming up. So what I'm probably going to do, we've got these book problems. I will probably also give you a review handout over the 2 sections from chapter 7. I'll probably give it to you either towards the end of class tomorrow or on Wednesday. And so then we'll pick up next week starting chapter 8. So the rest of this week